Second question of LeetCode contest 456, longest common prefix between the adjacent string after removal. So we are given a string words, and this words has basically the strings inside it, and we have to do the two operations. These two operations are remove the element at index I from the words array and compute the length of the longest common prefix among all the adjacent pair in the modified array. So what does it mean is we have to remove one by one all of them. For example, let's say at I equal to 0 we are removing this very first word, right? This string, if we remove, we have these three, right? This is one adjacent string and this is one pair of adjacent string. So what is the common here? Here CRIC and CRIC, this is common of length 4, okay? And here also if we go, this is CRICK and this also CRICK. So length is 5. So we found 4 and 5. So 5 is maximum. So here what we will do is in the answer array, instead of this, we have to put the 5. That when we removed this guy, we found the adjacent biggest value was 5, which was coming from this pair. Similarly, when we will remove this guy, this and this are a adjacent pair, and this also are a adjacent pair. So see here CRICK and CRICK of length 5. And here also CRICK. So we have found the 5 length. So for this location, when we remove, we will find the biggest adjacent common prefix was of length 5. Similarly, if we remove this guy, this and this would be adjacent, this and this also would be adjacent. So here also we are finding CRIC and CRIC. So 4 is the here, and when we are checking this guy and this guy, what is happening? CRIC. So we will get the 4 length. Similarly, we have to do for everyone, because once we remove one of them, all of them are the modified new adjacent, right? So we have to find in that way that what would be the answer of it. So for example, if we go ahead for this guy, what would be the answer of it? So let's say this is my answer array. Then what will happen if we remove this guy? We are finding CRICK, CRIC, CRIC. These are the common here, and in this pair we are finding CRICK and CRICK. So this is 5 length. From here we are getting 4 length prefix, and from here we are getting 5 length prefix, and we are interested to get the biggest value. So here what we will do, at this place we will write 5, right? Similarly, we have to remove one by one to all of them, the way which we have done for it. So let's say this time we are removing this guy. Okay, if we remove this guy, then this and this are adjacent. So what is the common? CRICK. So 5 is common from here and here. This and this having 5 common, and this also having 5 common. CRICK. So we will write 5 here when we remove this guy. Similarly, we will do for other as well. So let's say we are this time removing this guy, third guy. Okay, so if we remove this guy from here, we will check here what is the common here, CRICK, CRIC. So 4 is common between this and this. And what is the common here, CRICK and this guy. This has CRICK, this has CRIC. So CRIC is the biggest common. So we will write here 4. Okay, now we will remove this guy. Once we will remove this guy, we have to check among all these three. So this and this, it has CRIC, and this also have CRIC only. So this also would be 4 only. So this should be our answer. Okay, now the next thing is how to do that. Okay, so we don't have to do every time the recalculation of multiple things. So let's look for the key points. So far we have just found that what we have to do. So what we will do here, we will create a prefix array. This array would be of size n-1, whatever the bird's length -1. Why -1? Because we are here calculating the common prefix of adjacent elements. And if there is a n elements, then there would be n-1 adjacent pairs. Okay, so we will start from here. So first pair is becoming here, right? This 0th and first, right? So what is the common here? CRIC and CRIC is the common, which is of length 4. So first place it would be 4. Then we will compare this pair and this pair. Okay, in this pair what is common? CRIC and CRIC only. So here also it is 4 length only. Then we will compare this guy, last and second last. So what is the common here? CRICK and CRICK. So this is 5. So we have filled this prefix array with 4, 4 and 5. Now what we will do is we will create 2 more array, left max and right max. Okay, this array is only giving us the uh, the common prefix length for all the pairs. We have found these pairs, right? So then we will have the left max and the right max, two more array of same length n minus 1. Okay, so left max we will find the left max, and similarly we have to find the right max also. So this left max and right max would be giving us that what would be at ith index on left side, what is the biggest common prefix, right? And similarly for right side, whoever at ith index on right side, what would be the biggest common prefix. That thing we would be doing here. So what we will doing, when we were starting from here, we will see here this is 4, right? At very first location, first pair is having 4. So here we would be directly writing whatever is written in prefix. Okay, so we will write it 4 here. Now we will come to this location, second location here, what to fill. So whatever is there at this location I minus 1, and whatever is there at current prefix I. So 4 and 4, what is the max? So 4 itself is the max. So now we will add here. Now we have to fill this location. So we have to check whatever is there at left I minus 1 and the current prefix. So this is 4 and this is 5. So we will write here 5, right? So now you can consider here also, you can check it, that when we were starting at crick info, right? So this is the first place where we are finding a legit pair. Okay, so see here when we are starting at this location crick info, we have the 4 length on left side, we found the 4 length, right? Similarly when we were at here on the left side, again we found the maximum 4 length. When we were here on left side, we found the maximum 5 length, right, on the left side. Similarly we will do for right side. So when we are doing for right side, see this guy is the very right? No one is to the most right of it. So we will directly put this guy here. Now we have to fill this guy. So how we will be filling it? We will check with this guy and the current prefix I, right? So 5 and 4. So what is the max? Max would be 5. So we will put here 5. Now we have to fill this place. How we will fill? We have to find the whatever is the maximum in this I minus 1 and prefix of I. So 5 and 4. 5 is again the max. You can check here. When we are coming from right to left, you can check it here. See here, when we were at this place, what is the max? 5 only, CRICK, 5 length. When we are at this place, what is the max? 5 only, because we found the maximum till here. 5 is the common prefix in adjacent values. So crick, again here 5. At similarly here also the max would be this 5 only. So now we have found this prefix, left max and right max. Using these two, we will interpret our final solution. Okay, so let me show you my corresponding code here. So you guys can see here. First of all, I have written a utility method. This method, what it is doing, just simple thing. We are taking two strings and comparing that how many characters are same in these two strings, right? So see here, first I am getting the min length, because min length we want to run only that many times. Let's say we have two strings, one is 5 length and another is 3 lengths. So we can compare only up to 3 length, right? So that is why first I got a min length out of these two, and then I'm counting that how many are the common for from starting. Okay, so whenever they are common, we are keep on counting it. As soon as we are coming out of this while loop, we would be having the prefix count here, that how many are the equal starting from first location, right? So this method we would be using. Okay, so see here, first of all what we are doing, we have created one answer variable, and then we are taking the n length of the words. So see here, if n is equal to 1 or less than 1, we are returning this empty null array, because nothing would be there. When we would be removing that element, there would be nothing left, right? So we are returning as it is. Now see here, I have created a prefix array of n minus 1 length. Just same we created this one, prefix of n minus 1 length, because we would be having n minus 1 pairs. So what I am doing here is we are taking this way. So for I equal to 0 till I n minus 1. So why n minus 1 only? Because we have to find a pair. See here, we are doing I plus 1. So that is why we are stopping till I n minus 1. I is less than n minus 1. So what we are doing, we are calling on these two adjacent values this method. this method will be give us what is the common prefix length. Okay, so we found here for this ith location we found the common prefix and we are putting that length into prefix array I. Similarly what we did here for this very first prefix array. Okay, so in this way, once we are done with the prefix array till n-1, we would be having this prefix array of the adjacent things. Right now we are having these left max and right max for n-1 length. Okay, so see here, for left max the very first value is the same as whatever is the there in the prefix value, right? Very first value we fill it as it is. Now we are starting from I equal to 1 till prefix dot length, whatever is the length of prefix. So see here what I am doing, left max equal to math dot max of prefix I and left max of I minus 1, right? Same way we were doing here now. When we came here we are checking that what is the value at I in prefix and what is the value at I minus 1. So we were comparing these two and whatever is the maximum value we will keeping it here. Okay, so same way we are doing for the left max. Now we are going for the right max. We created this right max also, and initially whatever is the rightmost value in the prefix we have put it here, just like we did it here. Na? We initially directly put this value, whatever is there in prefix we directly put here, then we started from this guy, right? So similar we are starting here. You can see we are starting from prefix dot length minus 2 till I greater than 0, I minus minus. Now we are getting the whatever is the length maximum value in prefix I and right max of I plus 1. I plus 1 because we are going from right side. So if we are at here we are checking this guy and the current value of it. So see here, math dot max of prefix I and right max of I plus 1. So once we are done with the right max and the left max, then we have to check that. Okay, now we will be checking here. So see here we have used a for loop. Okay, and we are making an integer max equal to 0 initially. So see here, if I is greater than or equal to 2, okay, if I is greater than or equal to 2, we are populating this max equal to whatever is the math dot max of this max and left max of I minus 2. Because why this max I am taking? Because see here, at any location when we are at the, for example we are at this location, right, this I, then we are comparing this left guy and the right guy of it. Okay, because these would be the new adjacent, we are comparing them, and we are also looking that till the I minus 2, like for till this location what was the max common prefix. So we are putting that value here. So you can see here, first of all we are calculating this max equal to math dot max of max and left max of I minus 2. Okay, now in this case here what we are doing, if I plus 1 is less than or equal to n minus 2. Okay, if this is this I is till the second last element. Okay, or you can say it would be like n we created, so n minus 2. So in that way what we are doing here is max equal to math dot max of max and right max of I plus 1. Similarly, like when we are at here, see when we were at here, let's say we are at this location, suppose we are at here. Okay, so we will compare this guy and this guy, we will compare for max, and till here whatever is the max from the left side we will compare that. Okay, so we are updating this max. Now we are finally at this location, that if I is greater than 0 and I is less than n minus 1, then what we will do is we are taking the math dot max of this max variable and we are comparing this middle value with the left and right side, that what is the prefix length from left side and right side elements, immediate left and right of that ith index. Okay, so we are getting this max, and this answer I am populating for this max, and similarly we will be doing for all of them. Okay, and finally we are returning our answer. So let me run my code here. Okay, so let me try to submit it. So I am submitting it. If you guys have any concern, please make a comment over there. Thank you.